Hi, this is Mrs. Kidman, and in this video, we're going to be discussing how we can graph radical functions using shifting. Now, in our previous video, we talked about the parent functions of some of those radicals, and we talked about the square root function and the cubic function. Now, when it comes to these parent functions, these are the most basic of those functions. And what we're going to see is functions with different characteristics. So we might see something that looks like 3 square root x minus 2 plus 7. Something like this, that's a little bit more complicated and has different elements. But the beautiful thing about these radical functions is each element that's added adds something new and tells us something about what the function does. So what does each piece tell us? Well, let's take a look at this very generalized form. And we're going to go through each piece and describe what does it do and how does it affect our function. So let's start right here with this plus or minus. What this plus or minus does is it actually flips our function. And when we say it flips, that means it goes across the x-axis. So what we're looking at here is if I have a positive square root, so say I was graphing like the square root of x, we would have something that looks like this. But if I all of a sudden put a negative in front, what it does is it's now moved from being up here to being down here. So notice how it's flipped it across that x-axis. That's what that negative does, is it flips it across the x-axis. Same thing happens with our cubed root function. Now, the next piece here that we have is this a out front. Now, what that a does is it causes our function to shrink or stretch, depending on what the number is. Now, if our number is less than 1, it's going to shrink. If it's greater than 1, it's going to stretch. And what it does when it shrinks and stretches is we're talking about what the function looks like. So if this is our original function, when it stretches, it's going to look like this. When it shrinks, it's going to look like this. Notice how it gets a little bit wider. It changes the way that it looks. So that shrink and stretch will affect what our function looks like. Now, this n right here refers to the type of function. So remember, if it's a square or there's nothing there, then what it's going to look like is this. If it's a cubed root, we're going to get that little S shape there. Now let's talk about these other elements. So right here, we've got a plus or minus on the inside of our square root. Now this is different than the one on the outside. And what this one does is it actually mirrors our image. So when we talk about mirroring, what it does is if this was our original function, the mirrored function is now going to be over here. So it's like flipping it, but it goes across the y-axis instead of the x-axis. So it's going to take it straight across and it mirrors it. Now, what does this h do here? Well, this x minus h is actually a characteristic that we see in other types of functions, and you might have seen it in a quadratic function when it's in a vertex form. Now, this x and this h and this k actually have a special relationship where it helps us determine that endpoint and that center point. Now, how does it do that? Well, this h actually helps us determine if we are moving to the right or to the left. Now, if we see something like x plus 3 inside of our radical like this, then what that means is that we are moving 3 to the left. And if we see something like the square root of x minus 3, then that means that we're moving 3 to the right. So notice how it's kind of the opposite of what we think. The right is typically positive, the left is typically negative, but in this case, they're going to be switched. So if we see a plus inside, it's going to the left. If we see a minus inside, it's going to the right. Now, our very last term here is this k, and this k determines how our function moves up or down. Now, if we see something like a plus 7, then that means it moves up 7. If we see something like a minus 6, that means that it moves down 6. Okay, so looking at each of these elements, it actually tells us what our function does. And so the beautiful thing is I can graph it in a calculator if I need to, or I could try to graph it by hand by plugging numbers in. By using some of these elements, we can actually determine what it looks like before even plugging any numbers in, which is so awesome. So let's take a look at a couple of examples here, where we're going to look at what these different elements do and how we can use them. So very first, let's start with this square root of x plus 4. Now this plus 4 acts like our k here, and so that means it moves it up and down. So this function actually moves up 4, and so that's the only change it has compared to its parent function. So when we're looking at the endpoint, the domain, and range, really what we want to do is graph it. Now, when we say it moves up 4, it probably looks like this. But what does this function really look like? Well, let's go ahead and take a look at what happens when we pull up Desmos here. So as Desmos is loading here, what we're going to do is we're going to type in this function and see what it looks like. I'm also going to type in our parent function to see how it compares. So let's start first with the square root of x. What does that look like? Now you can see over here in red that we have our square root of x. Now we're going to do that square root of x plus 4 and see what happens. Now our blue one is our new one, and notice how it took the exact function and shifted it up 4. That's all it does. That motion is exactly what it told us. It goes up 4. Now what is our endpoint here? Well, because it moved up 4, our endpoint went from being at 0, 0 here to now being at the point 0, 4. It moves it up 4. Now, how does that affect our domain and range? Well, our domain is still going to be the same as the parent function, because notice how our x value didn't change. But our range is going to change to be 4 to infinity, because notice how it has nothing below the number 4. If I were to draw a line at y equals 4 here, there is no function down below that. So we know that it starts there. Similarly, this cubed root of x minus 2 actually tells us that it goes down 2. And we can graph it if we want to, but we can graph it on Desmos if we want to, but we don't need to. We can see that as we do this, our function will look like, that is not what it'll look like. It'll be kind of an S shape that then switches like this right there. Okay, so do we see how it switches? This line probably needs to be moved over a little bit. Drawing these cubed root lines can be a little difficult. So do you see how that center of change ends up right on our x-axis? So that's what we're looking for there. And that change point, or right here, is called our center point. And notice how it went from being 0, 0. Because it shifted down 2, it's now at 0, -2. So that outside number changes our y value there. And so our domain, our x value is still the same. So it's still 0 to infinity, but our range is now -2. Or our domain is not 0 to infinity, but notice how all of the x values still work. So it's still -infinity to infinity. And our range is still the same, -infinity to infinity. Now it does not change when it's that cubic function, but it does change when it's this square root function. Now we're going to take a look at one more example here of what this is going to do. And we're actually going to look at two. We're going to look at this example here and this example here and ask ourselves, what do these functions do? So this -3 here tells us that it's going to move 3 to the right. And this +4 tells us that it's going to go 4 up. And we also know that it's a square root function. So if the original one is here, our new one is going to go to the right 3, 1, 2, 3, and it's going to go up 4. And then it's going to look exactly the same. So notice how it shifted. Now, when we talk about the domain and range of this one, what we'll end up seeing is that that endpoint there really affects it. So our new endpoint in this case is actually going to be at the point 3, 4, exactly as it gets shifted. So instead of being at 0, it went over 3, or 3 in the x direction, and up 4, 4 in the y direction. And so that's where our new endpoint is. Now, because our endpoint changed, our domain and range will change. Remember, our domain, if our arrow is pointing this way, is going to start at whatever our x value of our endpoint is and go to infinity. If it's pointing this way, it'll actually go the other way. Now, our range is going to start at that 4 and go to positive infinity as well, because notice if we drew that line again at x equals 4, it'll go on forever. Now, let's take a look at this other one here and describe what this one does. Now, this one goes to the left 1. This -3 tells us that it flips, and this 3 tells us that it's going to stretch what it does, or it's going to get wider. So now let's talk about what this will look like. So our original function is going to be in black here. It's going to look like this. So our new one is going to move to the left 1, and then it's going to stretch. So instead of going over 1, up 1, because our other point was 1, 1, now it's going to go over 1, down 3. And so our new line is going to be a lot steeper, kind of like this. And notice how it's in a different place. So as we're talking about our endpoint here, our endpoint in this case is going to be at that 0, -1. But when it comes to our domain and range, they're going to be totally different. So our domain values are still going to, not 0, -1, -1, 0, sorry. Our domain is still going to rely on this number, and that's still going to be our lowest number, because notice how our graph points in the positive direction. So we're still going -1 to infinity here, but our range is going to be different. Notice how our range is now negative, and the highest point is 0. Because it's the highest point, we want to put it on the right. So we have a 0, and that's included, but then it goes down forever. The way we describe going down forever is a -infinity, and we want to write that first, because those intervals that we write for domain and range always need to go lowest value to highest value. So this is how we can use those transformations to determine what our graph looks like. Now, of course, you can always type your function into a graphing mechanism like Desmos or a graphing calculator. But if we didn't have that option or we didn't want to, we can always use these different shifts to see what our function does. And so that's how we can use different shifts on functions to determine what the function is going to do based on where it compares to our original parent function. So if you have any questions, feel free to reach out. But again, this is kind of a brief outline of what our function does and what it looks like and what each element means. So please reach out, but this is how you can shift a radical function based on the different elements we see in the equation itself.